So our objective is to write a program to get the values of coefficients of quadratic equation A, B, and C. And then accordingly, it will compute the solutions. And we know in one case, there is a unique solution. In one case, there will be two real solutions. And in the rest, and in the third case, there will be complex solutions. And Fortran gives us capability to work with real and complex variables. So let's write a complete program to do that. I have to write in the 7th column. So I would write program name quadratic equation. And I would write program quadratic equation. Right. To emphasize the strong typing, right? I will declare all of my variables by myself. So I have written implicit none, right? So all programs must be saved in the working directory. So our directory have been populated with these many programs. All these programs were developed during the class session, right? Quadratic equation dot for. So for input variables, as I mentioned, you should follow the standards of Purdue University for documentation of programs. So you must have real values for A, B, and C. These are the coefficients for coefficients of quadratic equation, right? We may have real solutions, right? Okay. X1 and X2. We may encounter complex solutions. So I would say CX1, CX2, right? And during the execution of program, we have to compute a discriminator, right? So very much like the algorithm. So first step, let's prompt the user, enter values of A, B, and C, right? And then let's read these values. So read A, B, and C. Since I'm using the asterisk in print and read statement, it means reading with the default option, right? Which means if the values are separated by comma or by a space or by a line, they will be read as separate values, right? Right. Now the calculation, leaving a line means I'm doing a separate, a distinct step. So here the documentation part should appear, right? So discriminant should be b squared. You can compute it b squared with b, that is b, minus 4 times a, that is c, right? So the mod is not going to be changed. So let's write 4.0. Now with the discriminant value, we are going for decision. So I would write if discriminant, and I'm going to use labels 10, 20, 30, right? So here is 10. The first block, value is negative. So I would start writing print. There are complex roots, right? So now let's compute the roots. CX1, right? There is going to be a real part and an imaginary part. We know how to define the complex numbers. So real parts will be given as minus b divided by 2 asterisk a, right? From the solution of quadratic equation, this is going to be the complex part, real part, right? And then that will be equal to SQRT of minus discriminant, right? It will be the complex part. If we are using the variables not as constants, therefore we have to use the function complex right here. And with the discriminant, again, there will be a division by 2.0 asterisk a, right? Real part and the imaginary part, they are written in the parentheses, right? This is the real part of the solution, right? And separated by comma, this is the complex part of the solution. And since I'm using variables, therefore I have used the function complex to identify, to convert these two to part of a complex number, right? Cx2, there will be only difference of negative sign, and that negative sign, let's adjust it over here, right? Now the other solution is 0, so 20. Say print asterisk, there is only one solution, right? And it is 0, so there is no difference. We would say print x1 would be equal to minus b divided by 2.0 asterisk a, right? And let's print the value. Asterisk, the only one solution is x1. Well, we haven't wrote the solution above, so let's write it here. Right, print asterisk cx1 equal to cx1, right? cx2. Know that this will be printed as such, and then cx2, right? The third block, 30, right? First message, print. There are two real solutions. Basic computation, x1 now will be equal to minus b plus SQRT of discriminant divided by 2.0 asterisk a, right? This is the first solution, and the second solution would be just with the negative sign, and that's it. At the end, I would like to write a dashed line, and here comes the program tip, right? So everything has been written correctly, right? We know that the programs are executed line by line. So if the program has gone here, it is at this point, right? Then in a linear way, it will go to the next line, right? So I have to get, since this is not a kind of a distinct block, to make it a block, I have to write here a GOTO statement, go to say 200, which means after this one, skip this part, right? So I will have a 200 here, and I write here continue, which means go to the next line, or you can have you can write here a print statement, print the end, the stop, or anything, right? So after executing this block, it will jump to this statement continue, right? The same is required. The same thing is required over here. That if it jumps to statement 20, so after executing these 3 lines, there is no need to go to the next step, go to the next line. It should skip these lines, right? So I have written go to 200, right? If you have any confusion about these lines or any of the program lines, eliminate those lines from your program and then see the effect on execution, right? That is the best way of learning, right? In programming, you don't have to trust anybody. Write the program, test it by yourself. If you are convinced with the logic and with the answers, that is the best thing, right? So we have saved the program. Now it's time to get to the running mode, and we have to develop the object file, execution file. So for that case, I would share the command prompt. So let's get to the command prompt. So we are here. We write. I have to get to G directory. And here I have 77 bin directory. Now compile quadratic equation.for. So quadratic equation dot. I'm still lucky. There are no errors, no compile time errors. So now let's test it. Quadratic equation dot exe or is understood. Enter values of A, B, and C. 2, 3, 9, right? So there are complex roots. Okay, right? Again, let's look for the values. I would say 1, 3, 2. There are 2 real solutions, but the solutions have not been printed. It means we have not used the print statement. There are 2 real solutions, so we have to update the program. So let's do it with the whole screen. So see here, there are 2 solutions, but we haven't printed them, right? So that is the kind of logical error. X1, I would say X1. Print X2 equals X2, right? Okay. So we have to again compile the program. We clear the screen, compile the program, and run it, and again with the 132, right? So 2 real solutions have been printed, right? So that is for the quadratic equation. Now you can add modalities to this program. Like you can, right? For example, if the value of A is 0, do we have to go for these many calculations? If this is if A is 0, then it is just bx plus c. So the solution would be minus c over b, right? And there is no need to go for that quadratic equation strategy, right? So you can add that one to your algorithm, right? If A is equal to 0, then directly compute the solution and skip the rest of the part. So if A is 0, execute this part, else go for the solution of quadratic equation, right? People sometimes do a step over here in order to confirm what they have read rightfully or not. After reading the values of A, B, and C, they prompt the user, do you like to correct your values? Is the input correct? Do you like to modify? So again, get back to the reading step, right? So that is the other modality that you should be able to do in your programs, right? So I'm leaving that part for you.